Let's talk about trigonometric integrals, also known as trig integrals. As the name applies, we use trig identities to manipulate these integrals and evaluate them. The identities that we mostly use are as follows. Sine squared of x plus cosine squared of x equals 1. 1 plus tangent squared of x equals secant squared of x. 1 plus cotangent squared of x equals cosecant squared of x. Another good identity to have is sine of 2x equals 2 sine x cosine x. Let's see, how about cosine of 2x? How about cosine of 2x equals cosine squared of x minus sine squared of x? And of course, if you remember from pre-calculus, cosine of 2x, I can manipulate this and write it in two more forms and write cosine of 2x equals 1 minus 2 sine squared of x, which is the same as saying 2 cosine squared of x minus 1. Okay. The other two identities that we need are the reduction identities or reduction formulas. One is sine squared of x equal 1/2 minus 1/2 cosine of 2x, and cosine squared of x equals 1/2 plus 1/2 cosine of 2x. Now, some of you may remember this sine of 2x right here as 1/2 1 minus cosine of 2x, which is the same thing, just, being the 1/2 factored out. Or you may have remembered the cosine squared of x as 1/2 1 plus cosine of 2x. Again, it's the same thing with being 1/2 being factored. So let's do a couple of examples. I'm going to go to the next page. Let's start with something really easy. Suppose I want to take the integral of sine cubed of x dx. And looking at that, we really don't know how to do this. But what we can do, we can use the identities like sine squared of x plus cosine squared of x equals 1. So first, let me rewrite this as sine squared of x times sine of x dx. Okay, so I hope you agree that I didn't change anything. It's the same thing. Now, after that, that equals the sine squared of x. I can rewrite that as 1 minus cosine squared of x times sine of x dx. Okay. And one more step, I can claim that this equals integral of 1 times sine of x is sine of x, and then I have minus cosine squared of x times sine of x, and all that dx. Now notice that this first part is easy. So this equals integral of sine of x dx minus integral of cosine squared of x times sine of x dx. So let's go to the next page. And so what is the integral of sine of x dx? The integral of, the integral of sine of x dx is minus cosine of x, okay? And then I'm left with integral of, minus integral of, let me just write it, minus integral of, and in one extra step, you don't have to, minus integral of cosine squared of x, sine of x dx. I just want to show my work in the same page. So here I can claim that let u equal cosine of x, du equals minus sine x dx, and dx equals du over minus sine of x. So there I am. So this equal minus cosine of x from here, of course. Then I have minus integral of u to the second sine of x, and with dx we said it's du over minus sine of x. And notice the sine of x nicely cancels out. So now this equal minus cosine of x. I have a negative here, times negative gives me positive integral of u squared du. So that equal minus cosine of x plus u to the 3 times 1/3, and here is plus c. And one last step, I can rewrite this as minus cosine of x plus 1/3. U was cosine of x, so I'm going to write cosine cubed of x plus c. Okay, let's do one more example. Go to the next page. How about something like this time? Let's do something like integral of, say, sine cubed of x, cosine squared of x, dx. Okay. So what I'm going to do here, and I should have mentioned to you that anytime you have one of them, to the odd power, that's the one that you want to use, the odd powers. That's the one that you want to break. So let me rewrite this as this equals integral of sine squared of x, cosine squared of x times another sine of x dx. And I hope you agree with me that I didn't make any changes, because sine squared times sine of x is sine cubed of x. So no change was made. Now I'm going to use the identity and Pythagorean identity and say 1 minus cosine squared of x times cosine squared of x times sine of x dx. And of course, now this equals integral of 1 times cosine squared is cosine squared of x. Then I have minus cosine to the 4th of x. Actually, better than that. Before doing that, let me just make my u, that way I don't have to have such a high powers. Let me say that in here that let u equal sine of x. I apologize. U equal cosine of x. Du equal minus sine of x dx, and dx equal du over minus sine of x. So now I can rewrite this integral as 1 minus u squared, 1 minus u to the second. Then I have, let me just get rid of this, I don't need it, times u to the second, and then I have sine of x, and dx is du over minus sine of x, and just nicely cancels this. Okay, and then I'm going to go ahead and distribute this u squared here and here. Let me go ahead and go to the next page. So that equals, bring the negative out, integral of u squared minus u to the fourth du. And of course, that equals negative, that equals to, well, one thing I can do here is I can actually notice that I have this negative inside, outside, and I have negative inside. I can just actually do that multiplication and write that as u to the fourth minus u squared du. Yeah, I like that better. I do like that better. So like this. So maybe in the previous step, when instead of having that negative outside, I do like this. Okay, that's better. I like that better. Okay, so this equals u 1/5 of u to the fifth minus 1/3 of u to the third plus some constant c, and that equals 1/5. We said that u was cosine of x, so cosine to the fifth power of x plus 1/3 cosine cubed of x plus some constant c. Okay, I'll do more examples in a different video so it doesn't get too long. Thanks.